Hi, this is Unit 4, Lesson 2, Graphing Quadratic Functions. So we're going to be graphing equations that include an x squared, and that's what makes it a quadratic, is that power of 2. So we're going to start like we did with our absolute values with the most basic function that's a quadratic, and we're going to fill in a table of values and plot those points to see what the shape is. So if we start in this table of values, our function is y equals x squared. So if I want to calculate y here, I need to square the -3. -3, if we multiply it by itself, is a +9. If you're typing this in your calculator, make sure that you have the -3 in parentheses. Otherwise, you will get an incorrect sign on your answer. So we'll just continue calculating and filling in the table. -1 squared is 1. 0 squared is 0. And you can see I kind of naturally stopped doing the parentheses when I got into these positive numbers. It's not wrong if you put it in parentheses, it's just that with a positive number, the parentheses aren't necessary. And I'm going to add one more to my table. 3 squared gives me 9. So we're going to plot those points. -3, 9. -2, 4. -1, 1. We've got the origin, 0, 0. 1, 1. 2, 4. And 3, 9. So in some ways, this is very similar to the absolute value graphs that we worked on last time. The absolute value graphs had a straight edge, something like this. So you can see that instead of having a nice straight edge, this quadratic has a curviness to it. And so we often say that it has a U shape instead of a V shape. And this shape is so common in math that that shape actually has a name, and that function shape is called a parabola. So you'll often hear me or your teacher refer to a parabola, and a parabola is just this quadratic U-shaped graph. The curved shape of the parabola is a result of the squaring process. So we're going to think about the perfect squares for just a minute. 0 squared is 0, 1 squared is 1, and we kind of went through these before. 3 squared is 9, 4 squared is 16. And so if we think about how perfect squares grow, first they grow by 1, then they grow by 3, then they grow by 5, and then they grow by 7. So we use this 1, 3, 5 pattern to help us graph the U-shaped parabola. So starting at the vertex, we go up 1 over 1, and then we go up 3 over 1, and then we go up 5 over 1. So each time we go over 1, and we use a 1, 3, 5 pattern for how we go up. Okay. As far as translating these U-shape around, it works exactly the same way that our absolute values worked. So instead of having squaring, before we had these absolute value bars, and we could use that sort of to figure out where to start the shape and then count the slope. Well, with a parabola, it works almost the same way. Instead of seeing absolute value bars in the equation, you're going to see some squaring. So we have our power that tells us that it's U-shape. We find our vertex the same way by focusing on these two numbers in the equation to get that vertex location. And then instead of counting off a slope, straight edge slope, the A value is going to stretch it and change the curvature. And in just a minute, we'll talk about how that works. So we're going to graph this first parabola. It just has a stretch factor of 1. So it's going to follow our regular 1, 3, 5 pattern when we graph it. But before we graph the shape on the coordinate plane, we need to know the location of the vertex. And so we look at these numbers here. Just like with absolute value, we have the horizontal sign change. So this is going to be +2 and +1. So here is the vertex of our parabola. And now we can use our pattern, and we go up 1 over 1. And then we go up 1, 2, 3 over 1. And then if we had space, we would go up 1, 2, 3, 4, 5 over 1. We kind of ran out of space on this one though. And then we need to go the other direction as well. So again, starting at that vertex, up 1 over 1, up 3 over 1, and then if we had some space, up 5 over 1. Once you have those points there to help you, you can sketch in your parabola. Sorry, when I'm on my tablet, sometimes my graphs look a little wobbly. So with parabolas, we often talk about whether they open upward or downward. So this one opens upward. Downward would look like this. So we have an upward opening parabola, and when it opens upward, it has a minimum, a low point. So this one does not have a max, it only has a minimum, and that minimum value is 1. So let's graph another one. Something that's different about this one is that we have a different stretch factor. We see a negative in front of it. And that's like a -1 for the stretch factor. Now on your homework, I think it calls this, it just asks for it as an A. That stretch factor is -1. So instead of a pattern of a 1, 3, 5, this is going to take that pattern and multiply it by -1. So it becomes -1, -3, -5. Our vertex, or starting point, we get from these two numbers. So it's going to be -3, +4. In the grouping, change the sign. The 4 sign stays the same. So -3, 4 is over here in the second quadrant. And so if we count off that pattern, down 1 over 1, down 3 over 1, down 1 over 1, down 3 over 1, now we can go down 5 over 1. That's the right side of the U. And now we need to also get the left side. So we're going to go down 1 again, then down 3 over 1, and then down 5 over 1. So there's our points, and we can sketch in the U shape. So this time the parabola opens downward. And when it opens downward, it doesn't have a minimum, it has a maximum or a high point. And in this case, our maximum value is 4. So if you see a positive stretch factor, it's going to open upward. If you see a negative stretch factor, then the parabola is going to open downward. All right, let's do a couple more graphs. So this first one has kind of a tricky vertex. So if you look over at the one on the right side, you can see that it's an x minus 4 squared, which puts our vertex at a positive 4x value. On this side over here, there isn't a number with the x inside the squaring. So that has an x value on the vertex of 0. And then the 5 is our y portion of the vertex. So this has a vertex of 0, 5, which is here. Our stretch factor, our a value in our function is -2. So our pattern is normally a 1, 3, 5 pattern for a U shape, but we're going to multiply that pattern by a stretch of -2. So our pattern becomes -2, and then -6, and then if we had space, -10, but often we don't have space for the 10. So if we want to graph our U shape, we need to go down 2 over 1, and then down 6 over 1. So that's like the right side of the parabola, and now we go down 2, back 1, down 6, back 1 to get the other side. So this parabola opens downward, and it has a maximum value of 5. Right here, our maximum is 5. We're going to write the domain and range of this parabola. Now, sometimes parabolas, especially one like this, are a bit misleading to people, and especially with the domain. And they want to say something like, well, the domain is maybe -3 to 3 or -2 to 2. But even though this parabola is kind of tall and skinny, these sides do keep extending out. It's just that they don't go out very fast. They're going down much faster than they're going outward. So you'd have to zoom out a lot to see that parabola getting wider and wider, but it would get wider and wider. So the domain for our quadratics is all real numbers. You can write it like this if you prefer. The range is not all real numbers, so we want to remember to do our range from the bottom to the top. So in this case, the lowest value down here at the bottom is -infinity, and we go up to 5. So you can see the maximum showing up in that range there. Okay, let's graph this one. We already wrote down the x-coordinate is 4. The x-coordinate of the vertex is 4, and the y is going to be -6. So 4, -6, it's way over here in the 4th quadrant. Our stretch factor is a +2. Oops, I wrote that in the wrong spot. Stretch factor of +2 means our pattern, it's going to be that 1, 3, 5 multiplied by 2. So it's going to be 2, 6, 10. Up 2 over 1, up 6 over 1, and I can't fit the 10. And then we'll do the other side of the parabola. And this is another sort of skinny one. And so we have a parabola that is opening upward. And so it has a minimum of -6. That's the lowest value. The domain of this parabola, as with all parabolas, is all real numbers, or you can write it like this. And then the range, I want to do that from the bottom to the top. So the lowest value, I already have marked from my minimum, it's -6, and it goes up to +infinity. Okay, we're just going to do that backwards now. We're going to look at the graph and try to come up with an equation for the function. So the first thing I need to know is the vertex, because the vertex goes into the function here. So the vertex of this is 3, 1. So this part of my parabola is going to be x -3 squared plus 1. And then I just need to check the stretch. Now, if there's not a number in front, then it would be up 1 over 1. But you can see that that's not quite right. So I need to think about how far up does it go before it goes over 1. And it looks like that stretch factor is that it's doubled. It's a 2. So that stretch factor of 2 goes in front like this. So we have f of x equals 2 times quantity x minus 3 squared plus 1. Make sure when you're writing these equations that you aren't leaving off the power. That power is what tells us that it's a U shape. It's very necessary. And without that power, it would actually be a straight line. Okay, we'll do one more. This one has a vertex right here at negative 4, 6. So we could write that as an x plus 4 squared plus 6. And then we just need to check our stretch factor. And it looks like it is going down 1 over 1, down 3 over 1, down 5 over 1. So this is a normal 1, 3, 5 pattern, but it's been reflected, so we need a negative. Now you can put the negative 1 if you want, but if you prefer, it's just as good to just have the negative symbol there, and that's like how we would write it like in a textbook or something. But having the 1 isn't wrong if you have it. So here's our function. Okay, we have this one last problem to do. Just kidding, 2 last problems to do. So this one asks us to answer a few questions about the graph, and then we'll write the equation very last. So the first question is, does this thing have a minimum or a maximum? And so this parabola is opening upward, and so we have a minimum value of negative 9. Now, we haven't talked a lot about intercepts yet this year, but you should be familiar with those from a prior class. So the x-intercepts are where it crosses the x-axis. So if we look at the x-axis, we have intercepts here and here at 2 and negative 4. And it's fine if you list those as numbers like that, or if you really want to, you can list them as points like this. It's your choice. The y-intercept would be down on the y-axis. And so this one has a y-intercept over here of negative 8. Or again, you could write it in a point form. Okay, so now it says, what is f of negative 2? So this is a quick review from Unit 1. So if we have a functions graph and we want to evaluate f of negative 2, we just have to figure out what the height of the function is if the x value is negative 2. So it looks like our answer would be negative 8. The function has a height of negative 8 for the x value, negative 2. Now this last one has a typo. We need to put this as, I meant for it to be negative 5, but the negative disappeared. I had some typo happening. So we want to find the x values when f of x equals 5. So we want to figure out an x value. That is not saying that the x value is negative 5. It's saying what is x if we know the function's height is negative 5. So here is a height of negative 5 right here. And you can see that the function hits that height twice. Hits it once on the way down. Now that's x equals negative 3. And then again, it has that height on its way up. And for this one, our x value is positive 1. Okay, the last thing is to write the equation. So our vertex is right here at negative 1, negative 9. And if we think about our stretch pattern, it looks like it's 1, 3, 5. So we just have a stretch of 1. So I'm going to write that in for now. So it's x plus 1. Don't forget to do a sign change. And then minus 9. And then don't forget to make it a U shape, we need the squaring. So I would probably normally not write the 1 there. If you have it, it's not incorrect, but I'd probably write it like this without the 1. The 1's just not necessary. Okay, we have one last problem. We have a function f of x that is given to us, and we want to create a new function by shifting it around a little bit. So I'm going to do this visually for the video. So we have a parabola here, and it has a vertex at -4, -3. So here's the vertex. Now it's a U shape. Because I'm not working on a grid, I'm not going to worry about counting out the pattern. I'm just going to kind of sketch it to remind myself that it's a little U shape. Okay, so now what we want to do is shift it 8 units up. So I am going to kind of try to count shifting it up carefully. 1, 2, 3, 4, 5, 6, 7, 8. So since I went up 8 from -3, that puts me now at a height of 5. And I also need to shift it 2 units to the right. So 2 units to the right. 1, 2. Wasn't a very good jump, huh? So if I started I was at -4 and I went 2 units to the right, I'm now at -2. So this is like our new vertex. I went up 8 and over 2, and here's my U shape now. So I can use this vertex that we got to here to write the equation. So this vertex is at -2, +5. So our function, our new function, g of x, is going to be x plus 2 squared plus 5. So I think visually a little sketch is a great way to do this. If you don't like writing out a sketch, I'll show you another way real quick. So it's here's our function. Anything that's going to move it up or down belongs in this position. Anything that's going to move it left or right belongs in this position. And this one has the sign change. So if I want to move it 8 units up, I am going to add 8 here. And if I want to move it to the right too, left, right, change signs. So if I'm moving it to the right, I'm going to subtract 2. And so you can see if you think about it that way, you get exactly the same answer. We get that g of x equals x, and this would combine to give us a plus 2 squared and then a plus 5. So we ended up in the same place. So you can kind of do it either way. You can think about it graphically on a picture, or you can kind of think about where each of those changes is happening in the equation. All right, so you have an assignment in your packet. Just one thing to watch out for as you're doing it is that it does definitely have some of these new parabolas in it with that 1, 3, 5 pattern to help us graph. But the homework assignment also has some absolute value functions. So be very careful to watch out for whether your equation has those absolute value bars, which make us have a graph with a V shape, or if we have that squaring happening, which gives us that U shape. So just watch out for that and make sure you're graphing the right one. If you're having trouble or if you need any assistance with this assignment, please talk with your math teacher. Thanks so much.